Hi CC family, I'm really excited about this Thursday because our science is really math and we're going to be learning about probability. And probability is the study of chance. So I have written off to the side here how we calculate probability. So we use P generally for mathematics, it's a capital P. P is equal to the outcomes over the total. And for this Thursday, our experiment is flipping a coin, and we are going to determine the outcomes for a fair coin. It is important to note that a fair coin has an even chance of it appearing on one side versus the other. So in this situation, I have a coin where it says yes and no on it, okay? That means when I flip this coin, I have the same likelihood that yes will appear as will be the chance that no can appear. Because it is a fair coin, it's not weighted any differently. You can skew coins to have a heavier weight on one side to make the other side more likely to appear up, and that is not a fair coin. So make sure when we do our experiment, you don't use any coins where you put stickers on it because that can change the fairness of our coin depending on the weight, okay? So for this coin, I want to talk about the probability of it appearing as, let's start with yes, be positive. So the probability that my coin could come up as yes is equal to the outcome. So when I look at my coin, I have one side that says yes, one side that says no. So there's a total of two sides. It's almost a little bit easier to start there. So I have two sides is the total. And the probability that yes occurs is one side out of the two when I flip it. Same idea now for the probability of no appearing. So the probability of no, the total is the same. My coin is the same fair coin, and there are two sides on this coin. So the total options is two sides, and the chance that I get no is one side out of the two. So the probability for this coin, because it is fair, is 1 out of 2, or 50%, we could say, if we want to change that into a percentage, is yes. And the same idea for the probability of no occurring is 50%, 1 in 2 tries. There are other possibilities. This one might be a little more challenging. We're going to talk about the probability of yes and no. A little bit tougher idea. So this coin, I want to find out what's the probability yes and no can occur. So the possibilities is still the two sides that I have. So that's the total. The total possibilities is the two sides. And when I flip this coin, if I flip it, oh, that was a bad flip. Let's try one more time. I have the option of getting one side, which in this case is no, but it's not yes and no. It's just no. Same idea if I flipped it and we'll pretend I flipped it properly and I got yes. Oh, I want yes and no. This is only just yes. So the likelihood that I get yes and no at the same time is pretty much 0. Now, I get a little excited about this, and I do think you should pose this to your class, especially for those with older students. The likelihood that you can get yes and no, because some creative minds might argue with you and say, what if, tutor, it lands on its edge like so? Isn't it yes and no at the same time? The likelihood of that happening is next to 0, and that's even kind of a word that you might hear. The book talks about it saying unlikely. It's pretty much impossible that when you flip a coin that it's going to not land on one of the sides. So the likelihood of that is there are 0 sides that say yes and no at the same. So the probability is 0. Okay? Now, my next favorite, and most English people are not a fan of this, is the word where they use or. So, what's the probability that I get yes or no? So let's start with the easy part. The total outcomes is there's two sides. So the easiest part is starting with the denominator of our fractions. Always start with the total because that makes it so nice. Now, what's the probability I get yes or no? So if I flip it, I got no, okay? So that was one time I could get that. I could flip it again. Oh, wow, I got lucky, guys. And it was yes, okay? So yes or no. It just has to be one or the other. So because I have one chance that I could get yes, and I also have one chance that I could get no, I end up adding those two together. And the probability of getting yes or no is that there are two outcomes for that. So the probability of yes or no is 100%. No matter what, when I flip this coin, I'm going to have a result, if it lands on its flat side, of it being yes or it being no. So those are the four possibilities of probability that you should talk about with your students. I think the and the or words can be confusing, so try to keep it kind of nice and slow with them. I think that the and, if you emphasize that the coin can only have one side facing up, it'll be easier for them to understand there's zero chance that yes and no is appearing. And only that argument of it maybe being on its edge could actually be entertained for the and possibility. Definitely an interesting discussion to have. So now let's talk about the experiment itself. So when you're working with your students, if you have an even number of students, you're going to want to make sure each person does the same number of coin flips, okay? This will make it easy because if you are using an even number, let's say I have 8, well, sometimes 9 students. So I take that number, whatever it may be, I times it by 2, right? And that is an even number, so it's going to be very easy to have whatever number I have be divisible by 2. And that is ideal because we're hopefully going to see in our experiment that whatever our results are, they get really close to 50% of the time it's heads, 50% of the times it's tails. Or my coin, 50% of the time it's yes, 50% of the time it's no. If you do not have an even number of students, you are now going to do yourself a favor and do the experiment with them, okay? Because now you as the tutor are going to add to it and you are now going to have an even number. The reason why is once you get your results, you're going to have some number. Let's just say we have, 30 results, okay? So let's say we get 18 heads or yeses, whatever your coin says on it, and we get, well, it should add up to 30, right, of the other option, which in this case would be tails if I'm using heads and tails. So, yep, 8 plus 2 is 10, carry the 1, 30. Good, I can add. So you might make it easier for the students to think, oh, what's half of 30? And 15 out of 30 would be that 1/2. So doing that even number is going to make it easier for them to reduce fractions in their heads, because I bet a lot of our students are not quite comfortable yet with fractions. So you want to really shoot for making sure the even number so that you can think about it as splitting in half. And I do know the younger kids, like the 4 or 5s, it'll be easier for them to think about it as splitting in half more than anything. I'm going to pause there for a second. Okay, so another thing that I want to make sure I talk about with you guys is the word independent. So each one of our coin flips are independent from anyone else's coin flips. Independence in probability in the study of statistics, mathematics, however you want to call it, is always where the experiment that I do at one moment does not matter if I do it again. So when I flip my coin, this option that I got here, I said yes. When I go to flip my coin again, it doesn't matter what my first result is. I still have a 50-50 chance that this could be yes or it could be no. My previous experiment has no dictation. So you might be going, well, it's more likely you'll get no because the first time you got yes. So it should be 50-50. That's not necessarily the case. In fact, I don't even know what I got. Oh, look, I got yes. Well, it's upside down for you. So you might even come to believe like, oh, 100% of the time this coin shows up yes. That's not the case. They're each time I do them independent. I think it's almost easier to explain where something is dependent on it. So I have a huge bucket of dice here, okay? I don't know how many dice I have. I don't want to know how many dice. If I go in here and I say, what's the chance that I get a D6, okay? And I pull one out. Oh, I got a D6. So this chance of me grabbing this has some set probability. Let's say I have 100 dice in here. So 1 in 100, I got this D6. Now let's say I go back into there. Oh, not quite. But now I go back in there. Notice my die is still off to the side. But now I don't have 100 dice in here anymore. I have 99. And I go digging in there. What's the chance that I get another, oh, it's another D6. I have a lot of D6. So now that is dependent because my number of dice decreased because I removed something. Now, if I did put that die back in there and shuffled it up, now it's back to being independent, where if I take a chance, oh, got another D6, right? And I put it back in, the probability is independent of what I pull out because I replace it back in. But if I start taking them out and I put them off to the side, independent means each time you do the experiment, it does not matter what happened before. Each time is different and going to have a result that doesn't matter. But dependent means we start removing things. Now we're changing the total. If you change the total, that makes it a dependent experiment. Okay, so I think that's really all of the things that I want to talk about for this Thursday. There is a little bit more for talking about dice and how like sometimes you can say something is fair versus it being unfair that I want to go in a little more detail. This is just for fun, okay? So like if we are going to eventually do experiments with D6s where we have a 6-sided die, and you'll notice most dies, all of them really, if they're a fair die, will have it where the 5 is on one side and then the opposite side to it is going to be a 2. Same idea with the 6. We are going to have opposite to it will always be a 1. And then the 3 and the 4. What happens with dice is that we can, as the user of them, roll them a certain way where it could become unfair depending on where the numbers are placed. This really happens for D20s, okay? So I have 2 D20s here. You see this special symbol that is marking 20 for this particular die. And you'll notice that it has 19, hang on, I'm trying to figure out, and then 18, nope, I gotta go the other way. Sorry, camera's inverted. 17, 16, 15. This die that I'm holding here is a roll down die. So it is not a fair D20. While this D20 that I have, you'll notice that we have 19 and then next door to it is a 3, a 1, then there's a kind of a disparate, the numbers are all spread apart where the large numbers are equally next to lower numbers. The reasoning for this is when you roll it, you could roll it if you're, a shark or something, where you get it where a higher number would appear if they're all on the same side. So like this die is considered unfair because all the high numbers are on one side of it as it rolls down to become a 1. Usually we use this for life totals in games. So if you have a total life of 20, you roll it down as you keep taking damage. While this is a fair die because it is equally weighted, no matter how I roll this, I'm not necessarily guaranteed a high number or a low number. And that is also partly why the D6s do that as well. If we had the 6, 5, 4 all like on the same kind of corner of the vertice of the cube, that would cause people to roll it differently so that they could get a higher result if they chose to. So that's why it is important to talk a little bit about the fairness of this coin. The reason why a lot of people will agree to a coin flip for a game to determine who goes first is because we all have this innate ability from tons of experience that the coins are fair. It's being flipped, there's an even chance that yes or no, heads or tails will appear. There are things called weighted die where sometimes they put a little metal weight inside of it, so that side is more likely to end up on the bottom, and then a higher number or a lower number, depending on the game, would appear face up, okay? So I do think that would be something fun to discuss with your kids, where if you were saying like, oh, let's use a coin flip to make a decision, a lot of people would be inclined to say yes, because an even chance, and that's one of our vocab words for this experiment, an even chance of one option occurring versus the other can happen. It is likely, so likely means probability is high, that things will be fair. It's unlikely things won't be fair because coins tend to be equally weighted on each side. So that would be a fun thing to discuss with your students. If you guys have any questions, feel free to reach out to me. If there's anything you want to add, put it into the comments. I'm just so excited for Thursday. I'll talk to you guys then.